I'm Anil Kumar, and in this video we'll understand how to calculate upper and lower bound using trigonometric functions. We'll take up an application where time to cross a river is the key to calculate. Let's assume that here's a river. Right? Let's assume this is a river and a person is rowing the boat, and the person is kind of rowing the boat and is kind of going in this direction. So because of the river which is also flowing, the boat actually kind of goes like this horizontally. Right? So that is how it goes. Let us assume that the angle which this boat is making with the horizontal is let's say 25 degrees. Okay. And let us assume that the velocity with which the boat is being rowed is around, let's say, some value, 4.25 meters per second. Let that be the velocity, correct? And let us take width of this river also. Let us say that the width of this river is in, let's say, 215 meters. So let's assume the width to be 215 meters. Okay. So we have taken width as 215 meters. So let me write down width is 215 meters. As in most of my videos, I normally don't say what is a significant digit or it is rounded to what. Now if I write 215 meters, what I'm trying to say here is rounded to whole number. Is it okay? Right. So it is rounded to a whole number. Okay. And as far as this velocity is concerned, this is speed. We are saying 4.25 meters per second. Now that is second decimal place, right? 2 decimal places, right? At times, we may also write this to 3 significant places. Both are same things. So 1, 2, 3. So 3 significant places or 2 decimal places. So this is rounded to 2 decimal places. And then we have the angle, right? So we say angle. Angle for us is 25 degrees. So 25 degrees is again integer value or a whole number. Let me write down integer here. These are, different options, rounded to nearest integer, right? So, nearest integer, right? Okay. So, if I have a whole number on an integer, it's kind of same thing. This could be written as 2 decimal places, as you can see, 100th, or it could be written as 3 significant places. Is it okay? So, both are kind of same things. What do we need to find here? We need to find time. Time to cross the river horizontally, right? So this horizontally, how much time will it take to cross the river? Now let me give you a formula here. Now time will be this distance divided by the velocity. So the distance, let me write general formula first. Distance over the velocity, right? So which is the horizontal velocity? Let me write horizontal velocity. Okay, so in our case, distance is 215, so we'll just write at present distance. And the horizontal velocity will be whatever is the velocity times cos of the angle. Cos of the angle. Let me write theta in general because we'll replace it with the upper and the lower values. Is that okay? So this is what is we want to find. So basically we want to find the upper and the lower limits of time to cross this river horizontally. Is that okay? So that is what we need to find. So to find upper and lower, least and maximum, okay, or minimum and maximum, least and maximum time to cross to the opposite end. Okay, so that is the scope of this question. How do we do it? So let us find the upper bound and the lower bound for all these three parameters which are given to us, right? So we'll write upper bound, we'll just write lower bound and upper bound for the values which we are given, right? So we have what all we have. We have three things here, okay. So we'll make three columns. So first thing, let's talk about width. Let's say width, W. 215 whole number. That is to say, we have to add and subtract. Whole number means 1. We have to add and subtract 1 over 2. Or add and subtract 0.5. Is it okay? So that is what we have to do. So if I add 0.5, I get a higher number, which is 215.5. If I subtract, it is 0.5 less than 215, so it is 214.5. Is that okay? So we get possible range for the width. As far as the speed is concerned, we have 4.25. Now in this case, we are talking about two decimal places, right? 100th, right? 100th place. So that means you have to, this is 100, this was round to 1, so 1 divided by 2, so it is 100 divided by 2, right? So that is a value which, 100 divided by 2 means times 2. Is that okay? So that value is 0.005, correct? You can also use the calculator to test, right? So it is 1 divided by 200. Right? That is how we get this in decimals, right? Which is 5 into 10 to the power of minus 3, which is 0.005, correct? 0.005. The other way is, when we are rounding, we have to add 5 to one more digit on the right. So 4.255, does it make sense to you? Just add 0.5. So in this case, we have 4.25, so add 0.005. Is that okay? And subtract the same value, 0.005, and subtract the same value. So the speed will be 4.255. Okay? So think it is 250. So 250 becomes 255, and lesser will be 245. Is that okay? So 4.245. Right. So anyway, you could use calculator also. Now as far as the angle is concerned, so we say angle, let's say theta is the angle, is 25 degrees. So 0.5 more will make it 25.5. 0.5 less will make it 24.5. Is it okay? So that is in degrees. Anyway, units are written there. We'll take care of units later. Now, what you need to understand here is that the time taken is distance over velocity times cos theta. Now, cos theta is coming in the denominator. So if I want, let us say, if I want the value for lower bound, let's calculate the lower bound. So we want lower bound for time. Okay, lower bound for time. So let's say that TL is equal to. Now, numerator should be the least. Is that we want this value to be lowest. Is that okay? So lowest value will be lower distance. So, or the width of the river. So we'll consider the lower value. Is it okay? Which is 214. So this is my lower value. Is it okay? 214. So we'll use this value, 214.5 divided by. Now if I want to make this lower, then in that case speed, should I use higher value or lower value? This is always you have to decide. You are dividing, it's in the denominator, right? Therefore, we should use the higher value, which is going to result into a lower time. Do you understand? Minimum time. So that should be 4.255. Now let's look into the cosine. So we have a video on this which explains why the cosine angles kind of reverses. Now, you know the cosine curve? The cosine curve is kind of like this. the value of the cosine function starts at maximum and then dips to 0 and then becomes negative as it moves along. So higher angle gives you lower value. Higher angle gives you lower value for cosine when you're talking about 0 to 180 degrees. Is that okay? Now in this case, theta is 24.5 and 25.5. You want higher, we want higher velocity, right? And we want higher cos theta because they're in denominator, right? To get the lowest time. So how do you get higher cos theta? You get higher cos theta for a value which is lower. So here we'll use this value for theta, right? So we'll write here cos of 24.5. Do you understand? Now sometimes if you have a doubt, what you can do is you can find the cosine values also, just to be sure, right? So let's find cos theta, right? So we'll do that. I'm just extending this. So we do cos of 24.5 equals 2. So we get 0.9099, and then we'll do cos of 25.5 equals 2. So we get 0.9025. Now it's easy to judge. We want higher value. Which one is higher? This one is higher. Do you see that? So it makes sense to use theta as 24.5. Correct? So that will give you the least time to cross this river. Is it okay? Now to find the upper bound, let me write down, we'll calculate later the value for the time, let's say maximum time. Of course, numerator should be high, so we'll take 215.5 divided by, this should be low, right? So lower velocity, so that we get high time, lower velocity or speed is 4.245. For cosine, we again want a low value, so that means higher angle, right? So 25.5. I hope this concept is clear to you, correct? Let's calculate. So in the first case, we have 214.5 divided by, within brackets, we'll do it again. 214.5 divided by, within brackets, 4.255 cos of 24.5 and 2 brackets close. Is that okay? Equals to. So we have this answer as equal to, let me write down this answer as 55.399. So let me write 40. Okay, let me write it 2 decimal places for the time being. Okay, now here the second one. It is 215 divided by, within brackets, 4.245 times cos of 25.5, 2 brackets close, equals to. That is equals to 56.11. Do you see that? Now these units are in seconds, meters per second. So time is in seconds. Is it okay? So what you find here is that the minimum time will be 55.4 seconds and the maximum time will be 56.11 second, right? So that is to 2 decimal places. If the answer you want time to 1 decimal place, you could round this off, correct? So in 2 decimal places, least time is 55.40 seconds and maximum time will be 56.11 second as calculated, correct? So I hope you understand how to use trigonometric functions and calculate their maximum minimum values or upper and lower bound. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.